All right. Hi, Algebra 2 students. Welcome to Lesson 4.2, where we are going to talk about another form called standard form of a quadratic equation and quadratic functions. If you remember back to Lesson 4.1, we were focused on vertex form, which was very similar to vertex form when we talked about absolute value equations. So now we're going to take the next step into standard form and what that is and what are the benefits of that. Okay, so if you take a look, objective for today, write and graph quadratic functions in standard form. And you can kind of see, here's the idea. Here's our parabola of this basketball. And who knows whether that one's going in or not going in. We'll take a look at that at a future time. Okay, so recall from the last lesson that a quadratic function is a function whose highest power of x is 2, any x squared. That's what we're looking at. And the graph looks like a parabola. It's a U shape, either opening up or down is what we're looking at. Vertex, remember, if it opens up, is therefore a low point and you have a minimum value. If the parabola opens down, then it is a high point and you've got a maximum value. Okay? Axis of symmetry, remember, is the line that cuts it right down the middle. And that vertical line always goes through the vertex because the vertex is located in the middle of the parabola. Domain and range, okay, as we take a look, we did not talk about this before, but if we remember back to domain, that is all possible x values. So if you think about that in terms of domain being, like if we're going back to a quadratic and we're squaring something, if you try to think of anything that it cannot square, remember we are talking about we can square negatives, we can square positive numbers, we can square decimals, fractions, zero. So the domain is going to be very similar to what it was with the absolute value functions, where the domain is going to be all real numbers, okay? Because of the fact that we can square any number that there is. Okay? Now, the range, on the other hand, if you remember, if it is opening up, okay, so let me put that. If it opens up, then your range is going to be that y is greater than or equal to whatever the k value is, your y coordinate of your vertex, okay? Or if you're thinking about that in interval notation, it would be, let me put that here, it would be whatever the k value is, and that should actually be a bracket, up to infinity, okay? So that's your bottom point all the way up to infinity. If your parabola opens down, then that's a different story. Oops, opens, not opened, spelled wrong. If it opens down, then y is going to be less than or equal to k. Again, the y coordinate of your vertex. Or you would go from negative infinity all the way up to that k value, that y coordinate of your vertex, including that. So that's what the range is going to look like. And again, we are very familiar with one form. Here's the vertex form that we talked about in the last one. Vertex is hk, axis of symmetry is x equals h. Okay. All right, so if we keep going then, here is what standard form looks like. It is very similar to linear, where we said ax plus by equals c. It's similar to that. We have y equals ax squared plus bx plus c, where a, b, and c will be numbers again, will be real numbers. Okay? And so if we take a look, the vertex is going to be, in order to find the vertex in standard form, because now, let me cover that back up for a second, I do not have the vertex here. You can't just look at the equation and take it out of it like you could with vertex form in the last lesson. So how do we get that? We take the vertex, and you can get the x coordinate of the vertex by taking the opposite of b over 2a. And if you think about it, when I put down here, where does this come from? Where you may recognize that, and you may remember it. That is coming from the quadratic formula. Okay, is where that's coming from. Quadratic formula is what's going on with that. And we'll take a look at later where that comes from specifically. Then the question is, how do I get the corresponding y coordinate? Well, just like you would at any other point, we would go through and you would just substitute your x coordinate back in, and that would give you the corresponding y coordinate. Okay, so we calculate that by substitute the x coordinate, I'm just going to abbreviate, back into the equation. And that will give you the corresponding y coordinate. So opposite of b over 2 times a to get the x coordinate, and then again, plug it back in, find the corresponding y coordinate. Axis of symmetry, just like before, is x equals whatever the x coordinate is. Before it was x equals h, now it's x equals opposite of b over 2a. Y-intercept is 0, c. If we start talking about, we start adding points now. So this is one of the benefits is if I were to remember, y-intercept is always when x equals 0. So if I plug 0 in for these two values of x up here, well, a times 0 squared, that's going to give you 0. B times 0 is 0. And therefore, your y-coordinate will equal whatever c is. Okay? So c is the y-intercept. So that's an easy one that you can pick out of the equation every single time. And a is still the same as it was in vertex form. Okay? So a tells you whether it opens up or down. And you can kind of think of that as the slope still. At least for your first set of points, you can think of that as your slope, okay? But only the first set of points. So if we keep going, when it says what is the vertex of the parabola for the following, and that's all we're going to do is find the vertex on this one. So to find the x-coordinate of my vertex, I would take the opposite of b, which is -5 then, okay? B is always in front of your x, over 2 times your a value. Well, a in this case is 1, so that means -5/2, -2.5 would be my x-coordinate of my vertex, okay? Or if you'd rather write that as -2.5, that's perfectly fine. So there's your x-coordinate. As long as you don't have to round, it's okay to write it as a decimal. We now take that and we plug it back in, and if I do that, let me plug this in and see what we get. -2.5 squared plus 5 times -2.5 plus 6. We end up with a y-coordinate of -0.25, -1/4. So therefore, your vertex is the ordered pair, -2.5, -1/4. And there's what we have for that one. Okay. If we keep going, let's try another one here. So if we go through and we take a look at the next one, again, x-coordinate, opposite of b, which is +7 then, over 2 times a, which would then be a -6. So -7/6 would be my x-coordinate. And we would then have to plug that back in order to get the corresponding y-coordinate. Okay? Now, obviously, that one's not very nice, so I'm going to kind of go through and skip that just for a second. I'll do it on a calculator here and see what we get. So we end up with -3 times -7/6 squared minus 7 times -7/6 plus 6. And we end up with a really bad decimal, and it turns out that it ends up being the y-coordinate is a +121/12, okay, is what you end up with. So these are not the nicest examples for coming up with nice numbers, but it's the same process. And if you can do the difficult ones, then obviously you can do the easy ones that do come out to nice numbers. So last example for you on this one. If you take a look, and I have 2 examples here. One of them you can kind of try on your own. For this one should come out a little bit nicer. X equals opposite of b, -2, over 2 times a, which in this case would be 2. Therefore, -1 is your x-coordinate of your vertex. Plug it back in. -1 squared is 1. 2 times -1 is -2. 1 minus 2 gives you -1 for your y-coordinate as well. So therefore, -1 would be your vertex in this case. Okay? So just to give you a heads up on that one, only thing I want to mention about number 4 is notice you have an x squared and you have a plus 5. Therefore, what you have to recognize is this is really the same thing as 2x squared plus 0x plus 5. Therefore, your b value is actually 0 as you're trying to find your vertex. Okay? So just kind of a quick heads up on that one. All right, so let's keep going here then. So now if we take a look at the graph, if I wanted to graph the following, let's go through and let's do that, okay? So vertex, first of all, let's find what we have here. Vertex is opposite of b over 2a. So if we do that, let me plug that in. X equals opposite of b is -2. 2 times a would be +2, so I get -1 as my x coordinate. And if I plug that back in, -1 squared plus 2 times -1 plus 3 should give me +2 as my corresponding y coordinate. So there's that. A value is in front of the x squared. That's a +1, which right away tells me that this is opening up. Okay, so I know that part of it as well. Y-intercept, here's the nice part about that one. When x equals 0, your y-intercept is sitting right here at the end as a +3, so I don't even have to calculate that. Axis of symmetry is x equals -1, goes through the vertex. Domain, we had already said the domain for all of these is all real numbers, okay, because you can square anything. And then the range, because this opens up, that means the vertex is a minimum value, so my range then is going to be y is greater than or equal to 2. And the 2 is coming from the y coordinate of your vertex. That'll be the lowest y value on this graph when we go through and graph it. Or again, if you want to write that as interval notation, that means your lowest point is 2, and it's going to infinity. That's another way of writing that. Bracket, because we're including the 2, just like we have the equal to sign under here. Parenthesis, because we cannot include infinity because it's not a number. Okay, so let's plot some points here and see what this looks like. Vertex is at -1, +2. Y-intercept is at +3. We know I have an a value of 1, so I can use that to find my first set. One of those points that will happen if I go up 1 over 1, it gives you the y-intercept, but I can also go the other direction. So here is another point that I know is on the parabola. And then if we sketch that in, I've got the vertex, I use the a value, I've got the y-intercept, so I've kind of used all the information I have. And now the rest then for now, we can continue to sketch in. Okay? And so if you notice, we said before that the range was 2 and up. Well, there's your lowest point right there is 2, and everything goes up from there. So the range matches with the graph that we're talking about. All right, let's do one more here. Let's try one more as we take a look at this. I think that's all I put in here for, yeah. All right, so let's try that. Same concept again, this time, as we go through and we find the vertex here. Opposite of b, so x equals -12 over 2 times a, which is -8, which means this is a +1.5. That's where my vertex is at, 1.5. If I then take that and plug it back in, -4 times 1.5 squared plus 12 times 1.5 minus 9 at the end gives me an answer of 0. So I have a vertex of 1.5, 0. A value is -4. It's in front of the x squared, which means right away, again, I'm going to know that that opens down when I graph this. Y-intercept, once again, is sitting right here. It is your C value, so the y-intercept is 0, -9. Axis of symmetry, once again, is x equals 1.5. That's where your axis of symmetry will be located. Domain, we said, is all real numbers. Okay, -infinity to infinity. And our range in this one, because it's opening down, that means it's going to go from negative infinity up to your vertex, which the y-coordinate is 0. So from negative infinity to 0, and again, that should be a bracket. We are going to include that. Or y is less than or equal to 0. There's your range. So now let's plot our points here. Vertex is at 1.50, right about there. We'll kind of approximate that one. Y-intercept is down here at 0, -9, so there's that. We can also use I didn't put the axis of symmetry in last time, but we can also use our axis of symmetry in order to come up with kind of a matching point, also called the symmetric point for our y-intercept, which means I can take that point and I can just reflect it. I know there's some symmetry here, so I'm 1.5 spots away. So if I go 1.5 spots over here, that means that I know I've got another point on the parabola over there. Okay, so we can use that symmetry to our advantage. So now I've plotted the vertex, I've got a y-intercept, I use some symmetry to my advantage, and now there is at least approximately what your parabola looks like. Okay, and again, if we check our range, we said it was going from negative infinity up to 0, that is our highest point. Or we said y is less than or equal to 0, there's that, all the way down. Okay? Again, I do not care which way you write your range, that's perfectly fine, whichever one makes sense to you. So then the last part here is if we go through and we talk about, sometimes things are useful, okay? And so if we went through and we tried to change these into the other form, okay, here's the idea. Let me do this for a second. Well, let's say we look at this one first of all. So a vertex form is obviously useful, so because we have the vertex, okay? But if I wanted to change that into standard form, the idea is I could go through and just multiply this all out, okay? Meaning I could take y equals negative. Remember what it means to square. I cannot distribute, okay? It means multiply by itself. So we would have x minus 3 times x minus 3. And then you still have a minus 4 here at the end. So if I go through and multiply this whole thing out, we have y equals negative, and I'm going to just put my answer in parentheses. If I multiply x minus 3, all I'm doing is distributing. I'm going to distribute the x, then I'm going to distribute the negative 3 and combine like terms. So that would give me x squared. I'd get a minus 3x and then another minus 3x for a total of minus 6x. And the negative 3 times negative 3 would give me a positive 9. Okay. The reason I put that in parentheses is because this negative out here. I now need to distribute that into the parentheses. So we end up with y equals negative x squared plus 6x minus 9, and then I still have that minus 4, which is the only thing left that I have to clean up. Negative x squared plus 6x minus 13 in this case. And there's the standard form equation for the exact same problem. Okay, notice a value right here is negative 1 in vertex form. A value is still negative 1 in standard form. Okay, I can come up with my vertex of 3, negative 4 very quickly. Now in standard form, I can come up with my y-intercept very quickly of negative 13. So again, there's definitely benefits of each one. Let's say I wanted to go the other direction. Let's say I was in standard form and I wanted to put it into vertex form. If that was the case, that means I need to find the vertex, okay, like we did earlier in the lesson. So the x-coordinate of my vertex is going to be the opposite of b, so negative 8, over 2 times a, which is negative 4. So the x-coordinate is 2, positive 2. If I then plug that back in, negative 2 times 2 squared plus 8 times 2 plus 3, that will give me a corresponding y-coordinate of 11. So that means my vertex then, if I just write that down, that means the vertex in this case is the ordered pair 2, 11. Now that I have the vertex, I can write this in vertex form, which if you remember is y equals a times the quantity x minus h squared plus k. And now all I have to do is just put the numbers in the right spots. Y equals a value of standard form is the same a value in vertex form. Therefore, that negative 2 that's sitting right up here at the top in front of the x squared, that is my a value. We have x minus the x coordinate of my vertex, so x minus 2 squared, plus the y coordinate of my vertex, which is 11. And there again is vertex form. Okay? So one of the things you should be able to do, just like when we talked about lines, is to be able to go from, we said before, go from point slope to slope intercept to standard when we were in the linear chapter. Now you should be able to go from vertex form into standard form or standard form into vertex form like we just did. Okay? So this lesson in general was about standard form and how you can, different pieces of it and how you graph it and all those kind of things. In order to give you some practice, what I want you to do is work on the 4-2 worksheet. And as usual, if you have any questions about this lesson, if something did not make sense, or you're working on the worksheet and you get stuck on something, please bring your questions to class, and we will definitely go over those and discuss. Okay? Good luck, and we'll see you in class.